we'll take the same example. If we look at fluorine and fluoride ion, so fluorine -1, and the question is which has the larger radius. I apologize for the poor handwriting. I'm writing without a pen. Let's compare, right? So if we look at fluorine, neutrally charged, and we were to look at the Bohr structure, it has 2 in the first shell, and then it has 7 in the second. If we compare that to fluoride, which is going to gain an electron, basically what we have is the same thing, but now an electron is added, right? So then the question becomes, between these two, which has a larger radius? It's actually fluorine -1 is slightly larger, as I'm just showing as zooming in there. Okay, now why is that? There's kind of 2 pathways you can use to explain. You can go the route of talking about how electrons and how all the electrons are negatively charged. And when you add an electron into that outer shell, they're repulsed by one another. They're going to try and move as far as they possibly can from each other to limit that repulsion. And in doing so, and moving as far away as they can, they're going to stretch that radius out a little bit more, and it's going to be larger than the fluorine neutral ion. So again, this is fluorine -1. Okay, so that's one possible way, is to talk about the electron repulsion aspect. The other possible angle of it would be to think about effective nuclear charge. When fluorine has 9 electrons, as shown in just the neutral atom, the nucleus, which I'll show you like a nucleus here, here's protons and neutrons, we'll say, in the center. So this nucleus has this effective charge that essentially has this attractive force that keeps these electrons in place and keeps them at a close proximity. If you add an additional electron, what happens now is that effective nuclear charge has to be split again to take into account another electron to hold on to. So you're going to weaken that effective nuclear charge and its attractive force to hold all of those electrons together, which then as a result will push the size of that atom larger. That'll cause it to increase its radius. Okay? Now, if you think of the other end of it, okay, we talked about a negative ion. What if we thought about a positive ion, right? Let's think of one that's maybe small-ish. Let's look at sodium, okay? So we can think of Na and Na+1. Okay, sodium, I believe, is in the 3rd row. Let me double check just by looking back here. Yeah, sodium's in the 3rd row. So we can see right here, it's on the left-hand side. It's an alkali earth metal. So that means it has 3 shells. So let's do this. We'll go Na1, 2, 3. First shell is going to have 2. Second shell will have 8. Third shell will have just 1. Okay, now if it's also being compared to its ion, Na+1, what that means is we've lost an electron. So take a look at what happens when you lose an electron. This electron goes away. And then effectively, the radius doesn't account for that empty shell. Now here's what you're dealing with. So that electron leaves. You can explain this in one of 2 ways. You can talk about how that shell essentially is no longer being used, so that radius then would shrink down naturally as a result. You could also talk about how that effective nuclear charge now, so this nucleus that exists in the center here, the attractive force that it has on all the electrons just went down by 1 number. So that effective nuclear charge that holds all those electrons in place just got a little bit stronger because it has one less electron to account for, because it's been removed or used in bonding now, right? So a positive ion's atomic radius would shrink, and a negative ion's atomic radius would increase. Okay, that's how you want to tie in ions with regards to radius. And you can use that explanation and understanding with radius to explain ionization energy and electronegativity. Okay, I hope this video helps. If you have further questions, please do not hesitate to reach out over the weekend or even over tomorrow, with it being Thursday. Yeah, tomorrow we have off. Okay, thanks, and I hope this helps.